We are always thinking about how we detect. We just detect, mercury is the next thing we want to detect. But if we don't understand the fate, the transport, and the transformation of the chemical in the environment and the human health, we cannot understand the whole story.
Hello and welcome back to the Pittcon podcast. In this episode, we'll be speaking to 2024's keynote speaker, Professor Omowunmi Sadik, about sustainable nanomaterials in sensing human health and the environment.
My name is Omowunmi Sadik. I go by Wunmi Sadik. I am department chair and also distinguished professor of chemistry and environmental science at New Jersey Institute of Technology, NJIT. I also hold the position of the Center Director for BioSMART Center, which is located in downtown Newark campus.
Fantastic. It'd be great to learn a little bit more about your journey as well. So could you tell us a bit more about how you've been in the field of chemistry, as well as your current role that you just mentioned at the BioSMART Center and New Jersey Institute of Technology?
I come from a family of, I would say my family really encouraged me towards going to sciences. I was born and raised in Lagos, Nigeria. I received my bachelor's and master's degrees at the University of Lagos. And then I proceeded to Wollongong University in Australia, New South Wales, where I received my PhD in chemistry. Since then, I moved to the US EPA, Environmental Protection Agency, where I did my National Research Council postdoctoral research in immunochemistry. And then after that, I went to State University of New York at Binghamton, where I began my independent career. I moved through the ranks as the assistant, associate, and full professor. I was there for 24 years. Then I moved to NJIT about 5 years ago.
Brilliant, thank you. So you are 2024's keynote speaker here at Pittcon, and your keynote presentation revolved around sustainable nanomaterials. What is meant by that term, sustainable nanomaterials, and what initially sparked your interest in this area?
Well, sustainable nanomaterials are materials that are derived from hopefully very low carbon footprint. You design materials with the intention that you want to minimize the use of volatile organic materials. You want to consider using biorenewable materials with 100% renewability, biodegradability. And what initially sparked my interest in that field was the idea that it is, every time you turn around, you hear of the negative connotations for chemistry, things like toxicity, things like volatile organics. We've gone through processes where we're worried about lead, worried about mercury, PCBs, polychlorinated biphenyls. But chemistry there's a lot of good things from chemistry. Chemistry had helped with pharmaceuticals that has helped to improve life and health. Chemistry has been has been pivotal to pesticides and herbicides that has improved food production. Chemistry had been central in terms of energy production. And so it is important that we begin to think about the role of chemistry towards sustainability. So when we talk about sustainability, we're always key. We think about the society, we think about the environment, and we also think about the economy. And so sustainability is a three-legged stool with people, with the planet, and profit. And so sustainability is key to us moving forward.
Thank you. And staying just for a moment on Pittcon's 2024 keynote address, how was it to be this year's keynote speaker, and how did you find the talk yesterday?
Oh boy, I've been coming to Pittcon for the last 30 years. I have attended several cultural keynote lectures, and it is delightful. to be named the 2024 Water Cooter Lecturer. I felt I was very delighted, and also, humbling, to think about the people who have, gone through that path and to be considered as one of them.
Brilliant, thank you. And in your talk abstract for the keynote, you mentioned the use of sustainable nanomaterials for understanding reaction mechanisms. Could you elaborate on how these materials aid in this understanding of this area?
Very, very well. So we need to understand the reaction mechanisms in order for us to address the unintended consequences of chemistry. But most times what you see is we are always thinking about how we detect. We just detect, mercury is the next thing we want to detect. But if we don't understand the fate, the transport, and the transformation of the chemical in the environment and the human health, we cannot understand the whole story. And so I believe the mechanism is critical, and the use of sustainable materials in understanding the mechanism is pivotal for us to understand its effect on human health.
Yeah, definitely. And staying on that very topic, your work has significant implications in biosensing, especially for pain biomarkers, as well as persistent pollutants. How do you foresee these applications evolving in the near future?
Pain biosensors are going to be necessary for us to objectively measure pain. Every time you go to the hospital and you have pain, the clinician, the nurses, the doctors will show you a face chart. And they will ask you the question on a scale of 1 to 5, how much is your pain? The issue with that is it tends to be very subjective. Pain is individual. In fact, the International Association for the Study of Pain defines pain as what this individual tells you. And if we continue to measure and assess pain the way it's currently being done, we're likely to exacerbate the issue of opioid crisis. Because if somebody comes to you and they say, "Oh, doc, I'm 10 out of 10," who are you to say, no, they don't have that? And so what we need to look at is create objective measure of pain. For example, we have devices like glucose monitors that have helped to measure objectively the level of glucose in people's blood. Why is it that we cannot look at biomarkers of pain and design similar devices to help us assess pain? And that is the reason for my work in pain biosensors.
And what is actually meant by the term biosensor for those who don't know?
Biosensors are small-sized devices. They consist of what we call the transduction. They also are closely connected with some biological molecule. The biomolecule interacts with the analyte of interest, and once the interaction takes place, there is a message that is amplified through the electronics, and they tell us what it is. And a very good example, of course, is the glucose monitor. Typically, the glucose monitor has a mostly electrochemical transduction, closely connected with an enzyme called glucose oxidase. The glucose oxidase combines with the glucose in the blood, and there is two compounds that are produced. One is gluconolactone, and the other is hydrogen peroxide. The gluconolactone is not electroactive, but if we measure the hydrogen peroxide, we can indirectly determine how much of glucose is present in the blood. And so that is a very good example of biosensor. There are so many other biosensors. We have biosensors for alcohol. When you get stopped by the cup and you've been drinking, you have a sensor right in their hands. We can design sensor for almost anything.
Brilliant, thank you. And your biosensor technology for pain assessment is quite innovative. What are the key factors that led to its development, and how does it work?
I was approached by a dear friend whose daughter was suffering from sickle cell disease, and she's always in crisis. And for the most part, it was difficult for doctors to be able to help her assign the level of pain she was going through. And she asked me, is it possible that we can design an objective way to measure pain? And I thought, to me, that should have been done, And so I said, we can do it as long as we can find a good transduction, we can find a good molecule to connect with that, we can design a sensor. So we did a literature search and we found that there's none. And that was really the origin of the work for pain biosensor. Okay, so how does it work? It is designed, it's based on looking at cyclooxygenase 2. Cyclooxygenase 2 is an enzyme that catalyzes the conversion of arachidonic acid into prostaglandins. Anytime you have prostaglandins, there's going to be pain. These are inflammatory markers. And so we now design a sensor that will measure the, COX-2, cyclooxygenase 2. That's one example. COX-2 has been around, he's been known for many things. He's been implicated in inflammatory diseases, osteoarthritis, neurological diseases, cancer. And so by focusing on COX-2, over the years, there had been substrates developed to bind to that molecule. For example, Advil, Vioxx, Bextra, although there are issues with all of those molecules, but they've been designed many times to understand. So if we understand the biochemistry of some of these pain inflammatory markers, then we can design sensors for it. That's how they work.
What are some of the challenges that you've faced in the research and development of nanomaterials that are economically beneficial yet environmentally benign?
The challenge is, first and foremost, we have to be able to convince people that the word sustainability is important and that designing sustainable materials is important. When nanomaterials, for the last 20 years, nanotechnology had been intensely studied. And at the earliest stage, two schools of thought came out. One is nano is toxic. The other is nano could be used for maybe biomedicine and some other applications. The first group, a lot of people did work to look at the environmental health and safety issues of nano. And because many organizations had been very proactive at the beginning to look at the EHS issues of nano, there are several. The most important I can mention is the NNI, the National Nanotechnology Initiative. The NNI had over 25 federal agencies involved. And so you had agencies like the US EPA, the National Science Foundation are taking proactive funding the researchers. And another organization that had been critical is the SNO. SNO is Sustainable Nanotechnology Organization. And for those who are not familiar with SNO, I encourage you to go Google www.sourcenano.org. SNO is a 501c3 organization. It provides a platform for practitioners of nano, scientists, engineers, social scientists, even economists to come and have the discourse on the pros and the cons of nano. And for the last 13 years, I am the co-founder of SNO. For the last 13 years, every year we meet and we discuss all of this. And so now there has been no showstopper for nano. And now the conversation is shifting from nano is toxic to nano could be made safe because of the proactive measures that individuals and organizations have taken at the beginning to see that nano could be designed sustainably.
Yeah, thank you for that. I'm sure our listeners who are interested in nano will go to that site and find that resource really useful. So thank you for that. On to the next question, which is just, can you discuss the roles of electrosynthesis and sonochemistry in the development of safe nanomaterials?
So electrosynthesis allows us to use electrons to initiate the design of nanomaterials. It is safe. It doesn't require use of volatile organic substances. Sonochemistry is also the same because you use sound in acoustics, and so it actually allows us to make materials, and these are components of green chemistry, photochemistry, sonochemistry, electrochemistry.
Brilliant, thank you. And you've already mentioned that you're the co-founder and president of the Sustainable Nanotechnology Organisation. Could you tell us more about the goals of the organisation as well as the work the organisation does?
I'm currently not the president, but I was the inaugural president and the co-founder. SNO was started by myself and Barbara Khan of the EPA and also NSF. And the goal was to create a platform for practitioners of nano to come together and have discourse on the positive and proactive development of nanotechnology. And now the goal of the organization is to look at the research, the education, and the responsible development of nanotechnology. And I believe that for those, for example, who've either taken the Moderna vaccine, COVID vaccine, or the Pfizer COVID vaccine, you already have nanotechnologies in your blood. So it is, at least the conversation is shifting towards applications, positive applications.
Pittcon Perspectives, unforgettable Pittcon moments from the experts.
And moving on now to Pittcon, where we are today. As we mark the 75th anniversary of Pittcon, could you share your first memory or experience of attending Pittcon and how it has impacted your view of the scientific community?
Thank you. My first Pittcon was in 1993. And that's more than 30 years ago. I was a grad student and I came from Wollongong, Australia. I was encouraged to come by my mentor and advisor, Professor Gordon Wallace, and it was exciting. I went on to so many of the technical sessions. It was just beautiful to see that many of the chemistry that we were doing in the lab, that we were not the only person, the others are doing the same thing. I was excited. And then I went to the exhibition floor and I looked at all of the companies and instruments that we've read about in articles, and they were actually there representing. I saw Dionex, I saw Waters Corporation, so many of them, Shimatsu, and I was excited. And since then, I've been coming to Pittcon.
Yeah, and what keeps you coming back every year?
What keeps me coming is, number one, the networking. At Pittcon, you get to network. You get to meet people who are the makers and the shakers in analytical chemistry and applied spectroscopy. At Pittcon, you get to see old friends and professors. I remember one of my first Pittcon conference. I joined the SEAC, the Society for Electroanalytical Chemistry. And there was a dinner. And I was sitting there. And right across this table from me was Professor Alan Bard, whose electrochemistry textbook was like Bible to me. And I was like, oh, that's Alan Bard across the street. I couldn't even go and say anything to him. But during the break, he got up and he looked at me and he said, so, where are you from? I said, I'm from Wollongong University. I'm a grad student. And I mentioned my advisor's name. But my advisor is pedigreed to Alan Bond, who is so well known to him. And he got up and he began to introduce me to all of the people across the table. And that is how I got to get into this community. And so to me, Pittcon provides such network. Another thing that's with Pittcon is there are short courses on different topics that you want to learn. There are the exhibition, there are the instrumentation. I love coming to Pittcon.
Brilliant. And also, the final question, what are you most looking forward to at Pittcon 2024 in San Diego?
I love the good weather. So they chose a very beautiful seaside location. As you know, at this time, we have snow on the ground in the East Coast. So I just love the beautiful weather. I love, again, the technical sessions. I am excited to I always love bringing my students. 2 of my students are presenting at this meeting, and I love the network.